Hi, so I'm next with the beautiful scripting. So beautiful scripting in the context of this LibreOffice in the browser, running in the browser as a WebAssembly thing. I think by now most of you have probably heard about it, and Thorsten already gave the trailer this morning about it. So what we do there is we have the whole of, or most of LibreOffice, not the complete thing because it's too big, still in some cases, so we drop like the draw or the impress and just have writer and calc, or you can combine them in any way. Just make sure your WASM blob doesn't get too large. And that gets loaded into the browser, and then you theoretically afterwards you wouldn't need any internet connection anymore because it's all local. You can wrap that into some whatever browser page, HTML, outer code, scripting code around that you want, and then you can, in this example, we just have a writer canvas rendered by LibreOffice itself, and all the GUI around it, all the controls there are done with some JavaScript Vue in this case, in this example case thing. So you can, there's a spectrum of you can have the complete LibreOffice GUI used, or just use some smaller widget from LibreOffice and surround that with your own controls, or your own drive that with your own logic. And for that, of course, you need some scripting. So what do we have there? All of this LOVA WASM stuff is built with this mscripten tool chain that allows you to compile C++, which LibreOffice of course still is, down to some WASM blob. And that brings along some mbind mechanisms that allow you to bridge between JavaScript and C++. So that looked like an ideal fit. So what we want to do in the end is have all of the API that is already available in LibreOffice, and that gives you a very rich and very fine-grained control of what you can do in the office. All of that we want to have available for the outer scripting layer that then controls what your LibreOffice code is actually doing, or what you want to do with that. For example, you want to have some data visualization in chart or calc and drive that from data that comes from the outside. So API is a perfect fit there. This mbind thing is not the exactly perfect fit there. It has some shortcomings or drawbacks that lead to then JavaScript code. So it was the easiest way to get something working, and it turned out that the resulting JavaScript code doesn't look too nice. For example, JavaScript does allow you, so it cleans up your garbage after you. It nowadays does allow you to notify you when something got cleaned up, get a finalization notification, so that you can then tell the C++ side, I no longer need this C++ object that got bridged over. You can also delete it on the C++ side. But that's a relatively new thing in JavaScript, that you can have these finalization notifications. So mscripten or mbind still insists that you always, when you get an object from the C++ side, use it, no longer need it on the JavaScript side, then call some method on it to go back to the C++ side to tell it I don't need it anymore. And that's, of course, not how you usually write your JavaScript code. Nevertheless, that's the basic technology that we have that's in there since sometime last year in the upstream LibreOffice. And but of course we can do better, way better. So what we thought about is just on top of this underlying mbind-based layer, which would be ugly to actually use, we have a much nicer zetajs layer. So the name is probably going to change over the course of the next days, as you just learned this morning. It's probably going to be a way cooler name, the cool JS thing, but the stuff in the box will remain the same, just a new name. It's layered on top of this not so nice stuff. And for example, it does require that your browser does support this object finalization so that you don't need to have these, I no longer need this object, mechanic or explicit calls, but all of the browsers these days do anyway, so there's no problem with that. And all of the all of the UNO things, all of the UNO objects, all of the UNO data structures, no longer like with the underlying case, tap into C++ objects on the remote side, and it looks more like you're writing C++ code in JavaScript, but they are all mapped to real, true JavaScript objects, arrays, structs, whatever on the other side. And you don't need any of these. So if you know the UNO API and try to program it, for example, from C++ or from Java, then you know about these dreaded query interface functions where you have a UNO object with many different interfaces, and when you want to use an interface, in another interface that you're not already have your fingers on, then you need to call this query interface to tell the code, I want this other interface, and that's very, very ugly as well. And long story short, what does it all look like? The resulting code is that much more cleaner, and if you maybe know the Python UNO binding, which has some of these similar niceties to make it more idiomatic Python code. In this case, it has some niceties to make it idiomatic JavaScript code. For example, at the top, we get hold of some object, of some document. It's a writer document, but we only know that from the file name, or even only from the content of the file. But then we get some model object that actually is a text model, but you wouldn't know that from the outside. So you would normally, if you wanted to get the actual text content out of it in the third line, you would have to do this query interface on this. You would need to know that there is some xtext interface. You would need to query interface on that. But here we already have all of that. That X model already implements all of the functions from all of the interfaces it supports. And if you would type this into a browser console to try it out actually in a live way, then you would also have code completion, because this X model that you get already has all the function slots filled in. So if you write get t, then it would complete it to the get text thing. 2 lines further down, you see we're iterating over something. What goes on behind the scenes is that there is some, can't even remember the name, constant star x enumeration, whatever UNO interface that then has some method asking, is there another, still more elements I can get, yes or no, and then there's another method to get the next element, and then you need a query interface, because what you get out of that is a generic any. So you would have like 10 lines to get that the next paragraph, and that's just an idiomatic JavaScript for blah blah of whatever iteration thing there. And if you want to set some properties, then you probably know this UNO stuff has these any values, where you have to explicitly tell it, I'm constructing an any that contains an integer or a short integer, a UNO short integer or a UNO long integer or a UNO double or whatever, and you don't need to take care of any of this here, so you just give it some number, color, and then it decides for itself, this looks like it could be a UNO long integer probably. So I'll make it into that and pass it over as that. Yes, but if you want to be picky, then you can still be picky, which is maybe a bit of an academic thing, but anyway, here we are. We are no longer here. Too much academic silliness. We'll get there. There we are again. So the top thing there is, so the problem is you want to get some any, and this any, as I said, can be very picky about what it is. It can be a zero that is long or short or float or double or a string or whatever. So in this picky world, you tell it exactly this is an any that has a type and an accompanying value, and you always need to tell it what type it is. Very boring. The top red one is what you get with this underlying emscripten mbind layer that I showed at the start. So you get something that is just in reality just a pointer over to the C++ data structure. This C++ anything, you need to get the value out of it with an explicit .get method. And when you're done with it, you need to do this delete to tell the JavaScript side that it can tell the C++ side that we are done with this object. If you would then call another get on it afterwards, disaster would ensue. The green one is the nicer zetajs or cool.js binding around it. You just get something, some A, and it is actually a JavaScript number. You don't have to do any guesses there. You can just use it as you go. But if you do want to know, is it a short or a long zero or a float or a double, then you can pay extra. And we have a kind of a shadow object besides the actual object. This $precise thing gives you all of the methods of the original object in a different kind, slightly different version, where all of the any's that you pass in or get out are wrapped in some JavaScript just type and value objects that you can then inspect to your liking, and you don't lose any of the information that you might or might not want to use anyway on these objects. And that's it. I stole my last slide, but anyway. There's a question.
Yeah, thanks. So I'm interested in what you said about the memory management stuff. I think you kind of mentioned that you would free stuff automatically when it was no longer used. I remember that in JavaScript there are some things with, like when you render stuff out, that you have to free manually still. What do you have any concerns about, like how long it might take for garbage collection to happen after you stop using a JavaScript object, and do you have any ways to like manually free stuff in zetajs as well if you're still like under load to stop memory from being used?
Yeah, okay. No, not really. So, yeah, if you would get under load, so this is a bit of a kind of a gamble on this will all work fine. So I was a bit surprised. I'm not coming from the JavaScript background at all. My idea about writing code for a browser is this is the wrong platform anyway for anything. That's my background and still kind of my belief. So I started out exploring into this JavaScript thing and thought, looks like it all works. So these runtimes underneath are pieces of sheer art and sheer genius how to make this all effective on using a language that has never been designed to be a real system layer language. And I was surprised at how well that all works and how really snappy that also all feels, because all these browser engines for JavaScript are apparently so well tuned by now that they're so snappy, even if you write crappy JavaScript code. So when doing this layer, I didn't explore into how to fine tune that in case there is need for that. But we could add that, of course. So there's still the chance to get this way of manually freeing it back into it if there's a need for it. Yeah.
Okay, so it all just generally kind of works in practice. Okay, thanks.
Yeah, thank you. Miklos.
In all the slides you mentioned JavaScript, but when we write code on the Collaborate Online side, we try to write all new code in TypeScript so that it's easier to deal with the growing code base. Is there anything on the mbind level or higher up somewhere to try to preserve all the type information of the underlying C++ code, which does have type information?
Yes and no. So there is the, or it would be possible to do this zetajs as a TypeScript thing. I did some experiments there, and oh, there we are again. So in theory, it would work. In practice, the question is it? So for some of the cases, it might be worth it, but for others, it might even be detrimental if you had too precise typing, because then you would need to go back to this C++ Java query interface route of having an Xtext, an X model that you get out of this load component, and then depending on what kind of file you're opening, you get an Xtext, Xwriter, or Xcalc, or whatever object. And this, of course, can't be specified statically in TypeScript. So we would need to get back to this. You either get back in any there in the TypeScript world, and then you're just as clueless as with a plain JavaScript, or you have to then annotate your code again with, I get something out of this, and I know it's a text object, but I have to annotate that somehow in the code. So for now, it's just plain JavaScript with leveraging the full benefits, in this case, of the dynamic typing. But could work. Thanks. Thor.
Yes, on this slide, when you called that create enumeration, couldn't the next line, it in theory know that it wants an enumeration because it's inside such a construct, so that you could have 4 expograph of Xtext directly?
Yeah, then it would get a bit tricky, because so of course, yeah, what we could do is look at this Xtext object, see if it has any methods that return an X enumeration, and if it has only one, then we suppose that we want to use that. Yes, we could do that.
You are free to use this idea.
Thank you. Anything else? Otherwise, I think, yeah.
Memory overhead. Have you noticed any bloat with this layer of JavaScript on top?
As I said, I was surprised that I didn't notice any bloat. So I just bravely ran with it and see where it starts to break, and then we'll investigate further. But for now, it's just this layer that is what it is for now. And let's see how far it gets us.
So can we get, for example, a portion of text of a paragraph and its properties, like is it bold, is it italic, or something like that?
Yeah.
I'm asking because, for example, in the future we may want to eliminate some of the set state callbacks from the core side and use that this information from AMP scripting to manipulate UI, online UI accordingly, maybe.
Yeah, that's all available in this rich API. So it gives you, in this example, we just changed the color of the complete paragraph, but you can also inquire on the properties that are given on each individual character, iterate through a paragraph's words and characters even, and go to extreme detail there with the API.
Thank you.
Thank you.